welcome to True Projects. In this video, we are going to explain about the project which is predicting residential electricity consumption using CNN BiLSTM SA neural networks. Before getting into the execution, first let us understand what is the project about. Nowadays, the world is using more and more energy every year, and our cities are growing rapidly. New technologies are emerging, and people are using more household appliances, things like fridges, air conditioners, washing machines, and everything in between. With this increased demand, we are facing two main issues. First thing is with the energy resources. So, energy resources are running out, meaning we can't keep consuming at the same pace without serious consequences. And the second thing is there is a pressure to keep up with the growing demand for stable and uninterrupted power. You can think of a simple example that can be seen in your daily life in your home. So, when everyone in the family use appliances at the same time, like running the washing machine while also turning on the air conditioner, so you might be running washing machine and air conditioner at the same time. So you might notice a drop in the quality of power or even a blackout. This is happening on much larger scale globally. The growing use of energy or residential, that is for residential purposes, driven by increase in the household appliances and our modern lifestyles, is making much more harder to maintain a balance between energy consumption and supply. That's why managing and forecasting electricity usage is becoming so crucial. So we plan ahead and avoid power shortages or outages. And now you think about it, understanding how and when household use electricity is crucial. Imagine if you could accurately predict when everyone will be using the most power, like it may be in the evenings. So when everyone is in the home or during heat waves when air conditioners are running non-stop. If we can predict that, that means if we can do that, we can plan power generation better and make sure there is always enough electricity, and even we can develop strategies to help people and save energy during peak times. But but the traditional methods which are used to predict this energy consumption, which is used for forecasting the power, don't always work that well because they miss out on how energy use changes over time, like how the consumption might spike during the summer but be much lower in the winter. So in summer, we consume more of electricity but low in the winter, and how it can be different across different areas. This is where the advanced methods like machine learning comes into the picture. This is where machine learning steps in. So these new techniques can analyze all the patterns and dependencies in the data that old methods missed, which lead to better prediction, fewer power outages, and more efficient energy system overall. It's like upgrading from a basic map to a GPS that gives you a real-time traffic data. So the main goal of this project is to tackle the issues we face with predicting electricity in the homes. It is not just about understanding how much power is used, but figuring out why and when certain patterns emerge for each household. By digging into the factors that influence energy use, like time of the day, seasons, or even individual habits, the project tries to uncover specific trends that can help improve how we manage the energy. So, in this project, we are trying to predict how much electricity people will use at home using smart combination, that is hybrid model called CNN by LSTM SA, which is mix of three powerful components. First, we have incorporated, that is we have employed convolutional neural network for that will help the model to understand the patterns over time, like daily or weekly electric usage. Then we have incorporated bidirectional long short term memory, that is by LSTM. So this will help the model to remember long term trends and relationships in the data even when they are spaced out over time. Finally, we use self-attention mechanism, which allows the model to focus on the most important data features and not getting distracted by irrelevant information. And to make sure that model is working with the best possible data, we have also incorporated the mechanism called maximal information coefficient, that is MIC, to pick out the most important features. This technique checks how strongly different features are related to each other and removes the ones that are too similar, ensuring we have diverse and meaningful inputs. So when it comes to the testing part, how well the model is performing, we use standard evaluation metrics that are nothing but R square, which tells how well the predictions match the actual values, and RMSE, RMSE is the root mean square error, and MAE, that is nothing but mean absolute error. This gives us a clear idea of how accurate and reliable the model is in predicting the electricity consumption. So this is about the proposed system. Moving on to the extension part. To further improve the performance, speed and efficiency of the project in detecting electric usage, originally we have used bidirectional long short term memory, right? That is BiLSTM. So now we are incorporating bidirectional gated recurrent unit as the extension part. In place of BiLSTM, we are incorporating BiGRU as the extension to make the model run faster while still keeping the accuracy intact. So think of BiGRU as more streamlined version of BiLSTM. It uses two gates. So it uses two gates, one an updated gate and also a reset gate instead of the more complex layers in the BiLSTM. This simplification helps the model to process large amount of data faster, which is really important when you are working with huge electricity consumption data sets, all while maintaining the model's ability to make accurate predictions. And here we have built front end using Flask framework. So we have built front end using Flask framework for easy user interaction with the model, complete with user authentication for secure personalized access. This ensures the system is not only functional but also user friendly and protected. Moving on to the implementation part, these are the steps followed in the flow of work to implement the project. Let's understand them. So first what we have done is we begin by importing the necessary Python libraries such as pandas, numpy, matplotlib and other required for data processing, visualization and model building. So we will be importing all the required packages. And then household power consumption. Here we load and analyze the data set which contains the household electricity consumption data to understand its structure and also key features. Then moving on to the other step, that is data visualization of electricity consumption of different submeters. We use graphs and plots to visualize the consumption patterns of various submeters, helping to identify the trends and anomalies in the data. Moving on to the next step, that is data processing. Here we remove the duplicate data. Any duplicate entries in the data set are removed to ensure the data is clean and consistent. And the next step is drop cleaning, where unnecessary or irrelevant columns are dropped to focus only on the important features. Then the next step is feature selection. Here we apply maximal information coefficient, that is nothing but MIC, to select the features that are not only highly correlated, ensuring we use the most relevant data for accurate predictions. Then we select the X and Y data. So here we separate the data set into features as X and the target variable Y, where X includes input features and Y represents the target output, that is electricity consumption. Coming to the next step, that is splitting the data set. Here the data is split into training and testing sets, ensuring that the model can be trained on the one portion of the data and evaluated on the other. So here we will be using training set to train the models, validation sets to evaluate the model. The next step is building the model. So here we create machine learning and deep learning models. Here we integrate CNN, BiLSTM, and also self-attention mechanism for the prediction purpose. And then the model is trained using the training data set. Here we adjust its parameters to learn from the patterns in the data. And then we evaluate model using metrics called R square, RMSE, and MA to assess the model's predictions. After that, what do we do is graphs are created to visually compare the performance of different models based on the R square, RMSE, and MAE scores. The next part is front end. So here, front end interface is developed using Flask to allow users to interact with the model, and a registration and login system is set up with SQLite to store the data securely. The next part is the user enters input values, that is features for electricity consumption prediction via the front end. The next step is the input data is processed at the backend to match the format expected by the trained model before making the predictions. Then the processed data. So the processed input data is passed to the trained model to generate the electricity consumption forecast. Then the predicted outcome is displayed on the front end interface, providing the users with forecast electricity consumption. So this is how we have executed the project. And now moving on to the algorithms used. These are the algorithms used to predict and forecast the electricity consumption. So these both are used as a baseline models to compare it with the proposed and extension model. This is the proposed model, that is CNN, BiLSTM, and self-attention mechanism. And this is the extension model, that is CNN, BiGRUSA. So here if you observe the change, here BiLSTM has been used and here BiGRU is used. Moving on to the requirements part, to implement this project, we need basic requirements, which are nothing but hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. These are about requirements. Now let's execute. To execute, we need to open the code folder which contains source code files. So let us open the code folder. These are the source code files in the code folder of the project. Let us understand each of them, how will they be used in the project. In the first folder, we have the dataset used in the project. Let us open it. So this is the main dataset that is used to train the models. Let us open it. It is being loaded. Just wait for a while. Until then, we'll understand about the other things. Here we have the test dataset. So this is the data set that is used to train the models for predicting the electricity. And here, these are the parameters. So these are the input variables. Based on this only, we will be predicting the energy consumption. So these impact how much energy will be consumed. Let's close this. And here in this file, we have the test data that we will be using in the front end to forecast the electricity use. Let's get back. And here in the models folder, we have the algorithm information that will be loaded into the project code during runtime of the application. Coming to static folder, here we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, in this we have HTML pages that are used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have Jupyter Notebook file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. So now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. It has been opened. Now give the command cd, give the space, paste the copied path, click on enter. So by giving this command and pasting the path here, current directory is changed to the code folders path. Now we have to compile the app.py file. So give the command python space app.py and now click on enter. So this command, it will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. So just wait for a while. Project is being loaded. App.py file is being compiled. And here we got the link. So this is the localhost and this is the port and this is the link where the application has been hosted. Now let's copy that. You can paste it in any web browser, that link. I prefer Google Chrome, so I will paste it in that. Paste link here, click on enter. So this is the web page of the project, which is displayed in the browser. This is developed using Flask framework. Now let's sign up, click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will log in directly, click on sign in, give your username and the password, click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here we can see choose file button, right? We need to click on that for uploading the test file that is in the sample folder. Let's open it. So let's open the dataset folder. This is the test data file that we will be uploading for checking the electricity consumption. Before that, let's see what is in the test data file. Open the dataset, open the test data. So these are the parameters. Based on these parameters, electric consumption will be predicted. That means it will be forecasted. And these are the different test values. So date date represents when the electricity consumption data was recorded. It helps to track the specific time period of the data collection. Coming to time, this indicates the time of the day when the electricity usage was measured. It provides temporal details which are crucial for analyzing patterns based on time. Coming to global active power, this is total active power consumption of the household measured in kilowatts, that is kV. It indicates how much power is being consumed at a given time. Coming to global reactive power, this measures the reactive power in kilovolt amperes reactive, that is kVAR. Unlike active power, reactive power doesn't do any useful work, but it is necessary to maintain the voltage levels in the power system. Coming to voltage. This is the voltage supplied to the household, typically measured in volts. It represents the electrical potential difference that drives the flow of current in the system. Coming to global intensity, this indicates the total intensity current, that is the current in amperes A consumed by the household. It shows the overall current usage at a given time. So these are different test cases that we will be predicting. For that, we will be predicting the energy consumption. Let's close this, get back to the application. So this is the file that we are uploading now. Click on open. It has been loaded now. Upload it. This will be processed at the backend and then we will be getting the prediction. So here, this is the first case that we have given. So for this case, this is the energy consumption predicted. That is 18.45964 on the date of 16/12/2006. Similarly, for all the given test cases, here we have the electricity energy consumption. Here, if you observe, you can see. Now let's check with the graphs. Click on graph. First graph represents the electricity consumption forecasting graph by the extension model. Here on x-axis we have number of test samples and on y-axis we have electricity consumption forecasting. Here green color represents predicted electricity consumption and red color is the true electricity consumption. Here, if you observe, both the green color lines and red color lines are colliding with each other. Almost they are colliding. So this means that this model, that is extension model CNN by GRU SA model, is predicting, that is forecasting accurately. And here we have R to score comparison graphs. Here on y-axis we have the algorithms that are trained for electricity consumption forecasting, and on y-axis we have R to score of all the algorithms that are built. And here we have RMSE and MAE. MAE, RMSE, and R2 scores are the evaluation metrics used to evaluate models which we have built in this project, that are regression models. Now click on sign out. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.